In section 6.4 we have some new trig identities, but they're not really all that new. So they go like this. We know this one. Now what happens if I take this and divide everything by sine? Well, divide everything by sine squared. Well, sine squared divided by sine squared is 1. Cos squared divided by sine squared, well that is cot squared, isn't it? And 1 divided by sine squared is cosec. Okay? Or I could start here and divide everything by cos squared, and I would get sine squared divided by cos squared is tan squared. Cos squared divided by cos squared is 1, and 1 divided by cos squared is sec squared. So those are my two new trig identities, and that's where they come from. Now, I find it personally quite difficult to remember exactly where, where the 1 goes, right? So this is cot squared plus 1 equals cosec squared. What you do need to remember, what I always have in my head is that I know that cot squared and cosec squared are kind of linked, right? There is an identity that links a cot squared and a cosec squared. I can never quite remember whether it's cosec squared plus 1 equals cot squared or cot squared plus 1 equals cosec squared, but I know that there's a link between cot squared and cosec squared. Same with tan and sec. I know that tan squared is linked with sec squared, and I can't remember which way around they are. So outside of exams, it's fair enough to just scribble this down and divide everything through by sine squared and just check which way around this one comes, or divide through everything through by cos squared and check where around this one comes. But you do need to have fresh in your head that tan squared and sec squared are linked, so that if you're in the middle of a question to do with trig identities, and if you see a sec squared, you know you could change it into something to do with a tan squared, and if you see a tan squared, you know you could change it into something to do with a sec squared. So if you had a sec squared, it would be sec squared minus 1 equals tan squared. You can use that identity either way, all right? So you need to have those links firmly in your memory. Now, if you're going into an exam, of course you want to have these learned exactly, because you want to save yourself a little bit of time in the exam. You can always double check it if you have time later on. People say, well, are they in the formula booklet? Now, honestly, I don't remember if these are in the formula booklet, and my answer is always, it doesn't matter if they're in the formula booklet, because you need to spot there's a link between cosec and cot squared. So cosec squared and cot squared. If you see a cosec squared, you need to turn it into 1 plus cot squared. You won't think, oh, maybe there's something in the formula booklet, I'll go and look in there. You'll just need to have that link in your head. If you've got the link in your head, you've basically memorized the identity anyway. So having the formula booklet isn't going to help you a great deal. You're really going to have to know your to know your identities, okay? And the other thing is, by the time you've done enough practice on the trig identities, these things will be in your head. So don't rely on the formula booklet, okay? Now, what can we do with these things? Well, there's a few examples here. On page 155, examples 11 and 12, I'm skipping over example 10 for the moment. This is just trig identities. Now, I don't have any new advice on trig identities here. I've given you if you look at the last video in this playlist, there's advice there, and if you go back to the videos from the trig chapter on the first year blue book, there's advice there. All the advice that I've given you is the same with trig identities. So if you've seen that, fine. I'll give you a quick reminder of the most important bits, which is, if you're stuck on trig identities, that is where the learning is happening. Don't rush into solution banks. Spend time getting it wrong. Try it again later, see if you can spot something else. Before you start, think of all the possibilities that you can use. Now we have these two trig identities. The other two that we know, sine squared plus cos squared equals 1 and tan equals sine over cos. I suppose we've also got cot equals cos over sine, and then we've got 1 over sine equals cosec, 1 over cos equals sec, 1 over tan equals cot as well. Start with the most complicated side, simplify it to the least complicated side. If both sides look equally complicated, just pick a side and see what you can do. And at each stage, think of all the possible options. So look for differences of two squares. Look for algebraic fractions that you can simplify, something that you can factorize out, terms that you can collect. Look for all of those sorts of things, and explicitly make yourself stop and think of all the possible ways forward, so that if you find yourself a couple of lines further down and you're stuck, you've got some plan B already in place, okay? That's all the advice I've got for you. The examples in the book, I think, work you through how to do those fairly in a followable sort of way. The only other thing I would point out is this sort of thing. tan A equals minus 5/12, and A is obtuse, find sec. Okay, now my way of doing this, you might know from another video, is not the same way that the book does it, but let's look at the way the book does this, because we can use these identities. It's one application of them. So if tan A equals minus 5/12 and I want to find sec A, well, I know that tan squared is linked to sec squared. So I need tan squared of A plus 1 equals sec squared of A. So if I plug in tan A, minus 5/12, and I square it, then I get 25 over 144 plus 1 equals sec squared A. So that gives me that sec A is plus or minus the square root of the answer to this sum. So that is plus or minus the square root of 169 over 144, which is plus or minus 13 over 12. And then you just have to think to yourself, well, is this the positive one or the negative one? The way they do that in the book is to have a cast diagram. The way that I would do it is to think of sec is 1 over cos. So it's going to have the same sign as cos. When cos is positive, this is going to be positive. When cos is negative, this is going to be negative. So you can draw a cos graph and say, well, an obtuse angle is going to have a negative cosine because we're in this bit here. Or you could remember what the sec graph looks like, and you can think to yourself, well, sec is negative when the angle is obtuse. Okay, so either way, the one that we're wanting is minus 13 over 12. Now, you'll know if you've watched previous videos of mine, or if you've watched that particular previous video, that I have a different way of doing this involving a right angle triangle and imagining all the angles are obtuse. Imagining all the angles are acute, and that'll still work. If you're trying to find sec, then all you need to do is find the cosine and do 1 divided by the cosine, and that'll work perfectly well. But this method's there as well, so I thought I'd do that since it's part of the examples in the book. So that's the end of section 6.4.